Okay, so we've talked about translations. In translations, the figure shifts left, shifts right, up, down. It's really a matter of left or right and up or down. The orientation never changes.
What is orientation?
Orientation is the way it's facing. If you look at this triangle up here, and let's say I want to look at point A, so the orientation is this facing down, right? So if I was using translation, the other triangles would all be facing the same way. Next, we talked about rotation or reflections. In a reflection, the figure remained congruent, but the orientation was always either the opposite going across the Y or the opposite going across the X. But the orientation was always opposite in one way or another. So a reflection, the shape remained congruent, but the orientation changed. Today we're going to talk about rotation. And rotation goes around a singular point. Again, we're in 8th grade. Most of our rotations are going to be made around the origin, the 0, 0. Okay. And that's just because all we're doing is an introduction to transformations, right? So our rotations, the point of rotation is always going to be the origin. So to rotate, we take a figure and we rotate it around. Rotation's patty paper is your friend.
I was about to ask that.
We're going to get there. You can use that. I have it up here. You can use it on assignments. Up here, I'm going to show you without patty paper. Okay? So my point here is to, again, give you multiple tools in the toolbox. Patty paper is a great tool. In rotations, it happens to be a beautiful tool because it's very easy to rotate it around and draw the dots. But there's always other ways to do it. Tomorrow we'll learn the way to do it algebraically. But today we're going to learn how to do rotations by rotating and using points. So let's look at number 1. It says graph the image of quadrilateral. What does quadrilateral mean? What's a quadrilateral?
A shape.
What does quad mean?
Four.
4. So quadrilateral is a 4-sided figure. After a 180-degree rotation, that means I'm going to rotate it 180 degrees. Here's where quadrants become important. So you've got quadrant 1, 2, 3, 4, right? So when I rotate it 180 degrees, what quadrant am I moving into? Quadrant 3. You're right. So let's take Q up here, and I'm going to rotate it 180 degrees. Now, the great thing about 180 is it just makes the signs opposite. So let's look at Q. What are the coordinates for point Q? What's the x coordinate? 4. And the y coordinate? 4. So 180 degrees, it's going to go into the negative negative, right? If you look at your sections, quadrant 1 is positive positive, right? X is positive, y is positive. Quadrant 2 is x is negative, y is positive. Yes? Quadrant 3, x is negative, y is negative. Quadrant 4, x is positive, I drew x, and y is negative. So right now we're going to make them negative negative, aren't we? Because they're coming out of this quadrant, aren't they? So what's 4? Negative 4. All we do is go over here and push negative 4. 1, 2, 3, 4. And then negative 4. 1, 2, 3, 4. And I hit Q. But what's Q now? Q apostrophe. It's a high comma. It's a comma that had a lot of Cheerios for breakfast.
Cheerios ain't very.
All right, don't be negative. So let's look at P. What's the coordinates for point P?
P. X 1, Y 4.
1, 3. So same thing. We'll just convert both times negative negative because we're doing 180, and we get negative 1, negative 3, right? 1, 2, 3. Yeah, because P was 1, 3. Right? So I get P apostrophe. Let's do R. What are the coordinates for R?
4, 1.
4, 1. Very good, Wesley. And I do the same thing over here. I go negative 4, 1, 2, 3, 4, negative 1, and I get R. Now, R apostrophe. S played a trick with us, right? S is going to go from this quadrant to quadrant 2, isn't it?
Yeah.
What are the coordinates for S right now?
Uno.
1, negative 1. So I'm going to multiply these to go 180. I'm going to multiply them by
2.
negative, negative. So negative 1, and what's negative 1 times negative?
1.
So negative 1, 1. And I get S apostrophe. Then I take my straight edge, connect everything up. So looking at this, are the figures congruent? Yes. Do they have the same orientation? Is the orientation, look at S, because S
No.
is the orientation the same? They are congruent, the shapes are the same size, but they've changed their orientation by 180 degrees. They flipped around, right? They spun. If I was using patty paper, I would spin it twice to get 180 degrees. They've spun 180 degrees. Does that make sense? So let's look at number 2. This one says graph the image after a 90-degree counterclockwise rotation. So what does counterclockwise mean?
This way.
The opposite way of clock.
So it's going to the left, right? So think about this as my quadrant, and I'm going to bring this down. What's going to happen to it?
It's gonna.
Negative.
I'm going from a negative positive to a negative negative, right? So what am I going to do to go 180 degrees or 90 degrees?
Flip it.
Well, let's pick a point just so we can play with it. Let's play with this point right here. That point would be negative 1, comma 1, right? If I changed it down here, because I rotated, I can rotate a point 1 point out. It's pretty easy, right? Yes or no? If I changed and I rotate this around that center, where would the point be now?
Negative 1, negative 1.
Negative 1, negative 1. What did I do to it? Did I change the x coordinate?
No.
Did I change the y coordinate?
Yes.
By what?
Negative.
A negative. So I can do the same thing, right? However, it's going to do a little flip in it. Does that make sense? The x and the y are going to change places. So when I do this, to do this top one, what I did was I multiplied x by negative 1. I made it negative, right?
Sure.
To do y, I multiplied y by negative 1. Down here, I'm actually going to flip them. In order to rotate it 90 degrees, I'm going to flip them. But I'm going to flip them with a negative in there. So to do that, I'm going to multiply my y coordinate is going to stay, my x coordinate is going to stay the same, but it's going to go on the other side. And my y coordinate is going to be multiplied by negative 1. So times y times negative 1. Does that make sense?
Do you have to do this?
Yes. Okay.
You can't just use patty paper?
Hold on. You can use patty paper, but you need to understand what you're doing. So rotating it, I am rotating it around. When I rotate point D and I bring it around, picture a circle. So point D is out here, right? I'm gonna use a pencil. Picture a circle from that based on, let's see if I can do this circle right. Based on the point of the origin, right, being my center point, I come around and I get so many points there, it's hard to see. That's a really rough circle. I go around, right? Well, look at point D right here. It's going to match up right here. Does that make sense? As I rotated it around, I twisted it around. Would be easier. Let's whip out the patty paper. Let's whip out the patty paper. So everyone, here you go, ma'am. Pass out patty paper. Oh, make the sad face. Then what I need you to do is make your XY. And then label your figure. Okay, so label your patty paper. Sorry, Tel wasn't here, so he hasn't played with patty paper yet. It's not only good under your burger, but it works for math.
I wouldn't want this on my burger.
Patty paper? It's in between all your
That's
burgers.
literally what. No, I know, but I wouldn't want it. It's clean and it's together.
Well, they take it off and they put it on the grill.
Why not?
Unless the guy is highly distracted. Then he doesn't get paid a lot. All right, now, to be nice to ourselves, I'm going to flip this over, and this is for Tel back there. I'm going to flip this over, and I'm going to darken. Make sure you darken off your thing. If you darken while you're over your graph, you end up with spots on your graph. So I went to the back and I darkened it because I want to make my very own carbon paper. Isn't that special? So special. Now, I'm 90 degrees and I'm going counterclockwise, right? So I get a rotating. I only rotate one quadrant. Yeah. And I got to match up my, that's why I made these axes, so I can match them up, right? And I'm gonna dot my points down here using my lovely carbon paper ability. Remember that this is point A. So down here, this is point A, apostrophe. I guess I can do that in pen here. So this point is point A, apostrophe, B, apostrophe, C, apostrophe, D, apostrophe, and E, apostrophe. Then I connect my lines.
Connect the dots.
Thank you. Connect my dots. Are the figures congruent?
Yes.
Are they the same shape, same size? Are they the same orientation?
No.
No, they've changed by 90 degrees. But let's take a look at what happened to them. So I'm going to pick point A up here. So point A, what are the coordinates for point A? What's the X?
6.
Not 6.
5.
Negative 5, right? And the y is 6. Good so far? On the board there. Now, A apostrophe. Let's look at the coordinates for A apostrophe. What's the x? Negative 6. And what's the y? Negative 5. Look what happened to the coordinates. X and y changed, right? So the new coordinates for A were negative y, comma, x. Do you see how that changed? It from xy to negative y, comma, x. Do you see how that changed? So our properties say we rotated the x and the y, and whatever y was, we made it negative. Can you see how we did that mathematically?
This is all math.
Yeah. All math. We love math. No.
So much.
We love math. Math makes us happy.
No, what makes the economy
That makes us
happy.
happy. Everything else in the world makes me ecstatic. Sorry.
See, that's the way to look at it, man. You just upped your levels. All right. Questions on rotations. Patty paper is a beautiful thing.
Yes.
Okay.
Only using patty paper.
You guys got to make it through this week before you get grumpy.
Too late.
It's Monday.
Patty papers.
I love Monday.
Yeah.
On Monday, I get to see you all.
It's only Monday.
That excites me.
I get to see